multiplying polynomials. Just like in your warm-up where it was 3x times 3x plus 1. Here, how did we do this? We use the distributive property. You're still going to be using the distributive property. You always use the distributive property to multiply polynomials. The only thing that changes is how that distributive property looks. So we're going to use the distributive property 3 ways. When you had a monomial times a binomial, you only had to distribute the monomial. But when we have a binomial times a binomial, you'll have to distribute more than once. You'll have to distribute each term in the binomial. So what that will look like is the 3x is my first term, and I'm going to distribute it with every term in the second binomial. The negative 1 is my second term, and I'm also going to distribute that to every term in my second binomial. Do we see how we got to this step? So then we do it. 3x times x is 3x squared. 3x times 7 is 21x. Okay, so then you distribute the negative 1 to the x and the negative 1 to the 7, and we get negative x minus 7. Am I done? What will I do next? Combine like terms. Simplify. 3x squared plus 20x minus 7. Remember, sometimes you would have to multiply your monomial across 3 or more terms. So we're going to do that with a binomial and a trinomial here. Everything in my first binomial is going to be multiplied across everything in my second polynomial. X squared will be multiplied with everything 5x squared plus 2x minus 4. And negative 3 will be multiplied with everything 5x squared plus 2x minus. So distribute your x squared to all 3 terms. 5x to the 4th plus 2x to the 3rd minus 4x. Yes, it should be 4x squared. Good catch. Okay. And then what? Combine like terms. In this case, we only have one pair of like terms. You will see times where you have more than just one pair of like terms. 5x to the 4th plus 2x to the 3rd minus 19x squared minus 6x plus 12 plus 12. Any questions on those? So you're distributing. Here's another time you're going to distribute. But it only can be used when you have a binomial times a binomial. Because FOIL stands for first, outside, inside, last. It's just a way to remember distribution. So when I have a binomial times a binomial, the first thing I'm going to do is distribute the first term to the first term in each binomial. So 4x times x is 4x squared. Then I'm going to distribute that 4x to the outside term. So what do we get? Minus 20x. Notice I've just distributed my first term to the second binomial. Inside means the second term to the first term. So 2 times x is 2x. And last means the second term in the first binomial to the second term in the second binomial. And we get negative 10. So I've just distributed the 2 to both. I've literally done the same exact thing we did here, but that step where I had to rewrite it is gone. because I used my mnemonic device of FOIL to remember first, outside, inside, last. Same thing, just looks different. So then we combine our terms when necessary. 4x squared minus 18x minus 10. Okay, let's do it with the second example. First, what am I going to get? Negative 16x squared. Outside. Inside. Last. Oh, negative 16x squared minus 14x minus 3. This only works for binomial times binomial. Now we're going to use the box method. The box method is just another way to organize your distribution. We're going to show you with binomial times binomial, but honestly the box method I would only use when we had more than binomial times binomial to keep everything organized. Okay? So we take our two terms and we organize them outside of a box. (3x times 5x is 15x squared. 3x times 2 is 6x. Notice I just distributed the 3x to both terms in my second binomial. I just went negative 1 times 5x and negative 1 times 2. So do you see how I just distributed my negative 1 to both terms in my second binomial? It just looks different. We're still distributing. Everything we're doing today is the same thing. We're doing distribution, but it might look different, and it's based on your preference. So then I have 2x terms, so I'm going to combine those when I write my final answer. So, like I said, I would not suggest the box method for a binomial times binomial. I just wanted to show you that it is distribution because it's the same thing that we've done every time in this column. So let's look at a binomial times a trinomial, which the box method could be something that you prefer because it helps keep you organized. So it's 2 terms times 3 terms, so make your box a little bit longer. 2x plus 8 times 2x squared minus 3x plus 6. 2x times 2x squared. 4x to the third, 4x cubed. 2x times negative 3x. Negative 6x squared. 2x times 6. 8 times 2x squared. 16x squared. 8 times negative 3x. And 8 times 6. So notice when you have like terms so that you can combine them. We have 4x to the third plus 10x squared minus 12x plus 48. Any questions on how I got any of those terms? Okay, you don't need your Chromebook just yet. I'm going to show you an example with a geometric figure. So right here, just draw yourself a trapezoid. Now, does anyone know how to find area of a trapezoid? So generally I will be giving you the formula for a trapezoid. So if this is 5x minus 4, and this is 3x plus 2, and this is x plus 1. Using the formula, let's fill it in. 1/2, base 1 can be either of my bases, 5x minus 4 plus base 2, 3x plus 2, times height. Simplify. What's inside my parentheses? 8x minus 2. Can you take half of 8x minus 2? What is it? 4x minus 1 times x plus 1. Okay. Since it's binomial times binomial, let's use FOIL. What's my first? 4x squared. Outside. 4x. Inside. Minus x. Last. Okay. And then you can combine your like terms. 4x squared plus 3x minus 1.